So in Unit 2, we begin Chapter 3, Section 1, which is entitled Functions. The first question in our assignment is state the domain and range of the following relation, then determine whether the relation represents a function. So there's a lot of vocabulary words here. So to do this problem, we have to understand one is the word relation. What is a relation? So a relation is going to be what we call a set of ordered pairs. So these little braces are what we call set notation. So what we put inside here is what we're talking about, what our set is. Our set here is ordered pairs. Remember, an ordered pair is when you have parentheses and there's an x coordinate and there's a y coordinate and you close a parenthesis. That's an ordered pair. So we have the set of these ordered pairs. And a set of ordered pairs is going to be called a relation. And what we want to do is we want to state the domain and range of this relation. Well, the domain is going to be the set of x values. The range is going to be the set of y values. So the x coordinates are the first coordinates. So the -7, the -6, the -5, and the -4 are our x values. The y values are the 2, the 2, the 2, and the 2. So there's only one y value. A function is something that is described this way. A function exists when input values, which we'll be calling the x values, they're going to be called the domain. It's going to go through a series of calculations, which is going to be some type of formula. Oops, didn't spell that very well. So a series of calculations is what we would call a formula. And the result is going to be what we call output values or our y values, which we would call the range. So again, for a function to exist, each x value can only be assigned exactly one y value. If a relation is going to be a function, the x values cannot repeat. So that's a little note there. So if a relation is going to be a function, the x values cannot repeat. So a model for a function looks like this. It's kind of like what I call my little function machine. So it's fed with input values or our x values. It goes through some type of calculations inside here, and it can only kick out one y value. It cannot kick out two y values. So if x goes in, say if I pick, say, a 3 for x, it goes through a series of calculations, and it decides to kick out a 5, that would be what a function does. If I have a function where if I say I put that 3 again in, and it goes through a series of calculations, if it kicks out, say, a 7 and a 5, that cannot be a function. So notice how the 3 would be paired with the 5. That's fine. But if a 3 is paired with a 7 and the 3 is also paired with the 5, that cannot happen in a function. So this is not a function. This is going to be what a function does. This is. So if you see an x value assigned to two different y values, that cannot be fitting the definition of a function. So in our problem here, the domain is going to be the set of x values. So it's going to be the set of, notice how the braces are already here. So all I have to do is list the x values. So the -7, comma, -6, comma, -5, comma, -4. They don't have to be put in any kind of order, just list them. The range is going to be the set of y values, and we don't have to write it more than once. So since there's only one y value, that's going to be okay. So the question is, does this relation represent a function? Well, notice that if -7 goes through the problem, it kicks out a 2. It only was assigned one y value. I don't see another -7 anywhere. So it means it's not paired with two different y values. The -6 goes in, and it kicked out also a 2. But I don't see a -6 kicking out any other values. So the -6 went in, it kicked out the same y value, which is fine. the -5 goes in, it goes through a bunch of calculations and it kicks out a 2. And again, I don't see a -5 with any other y values. The same way with the -4, it's only paired with one y value. So that's going to meet the characteristics of a function. So this relation is a function because there are no order pairs with the same second element and different first elements. So let's see. We do have the same second element. So that's not what we're talking about. We're talking about the first elements cannot be the same. So it is a function. So it's either got to be the first choice or the third choice. The relation is a function because there are no order pairs with the same first element and different second elements. So notice how I do not see the x value repeat. I don't see the same first element and different second elements. So this is a function because no order pairs with the same first element and different second elements. Okay, so a relation is going to be a function where no order pairs will have the same first element and different second elements. So let's read that one more time. There is a function, the relation is a function because there are no order pairs with the same first element and different second elements. So that's what we're kind of seeing, is we're not seeing the same first element paired with two different y values, if you will. So that's going to be the characteristics of a function. So that would be our description there.